Hello everyone, you're welcome once more to NEPH, your YouTube channel where we take care of problems covering a variety of areas in math. And today we have a problem on the board. You can do well to pause the video and attend the question. Okay, the question is actually a problem on series. Okay, I know you must have come across problems on sequence and series, your arithmetic progression and your geometric or harmonic progression. So all these are different kinds of progression or sequences in sequences and series in maths. All right, so I'll give an example of what I mean by you know series and sequence. For instance, if I have three, if we add two to this, we have what, five. If we add two to this, we have what, seven. If we add two to this, we have nine. So such a sequence is called arithmetic what? Progression. So that's a good example of what the word sequence. All right, we can also have what we call GP. Geometric is either it increases by multiplication or division. So if I have, let's say 5, I multiply this by 2, we have is 10. I multiply this by 2, we have is what? 20. I multiply this by 2, we have is what? 40. So it goes on and on and on. This is geometric what? Progression. All right, so for the question, that we have on the board, somehow we have to identify what kind of a sequence is this. But if we look at it, let's check. We can't multiply something to this to get 5, such that if we use that same number to multiply 5 to get 10, or to multiply 10 to get this. All right, so from that, we can observe that it is not geometric. And if we also look at it, it does not have a common difference. Remember, the times are 2, 5, 10, 17. Okay, so 5 minus 2, we have is 3, 10 minus 5, we have is 5, and 17 minus 10, we have is what? 7. So if you look at these values, they are not representing a common what? Difference. So these are not common differences, so we can't say that this sequence is what? An arithmetic progression. But such a problem, how do we solve it? The simplest way we can solve it, since the terms, you can see the differences are going by what? We have the difference of this is the consecutive odd numbers coming out. This is 3, this is 5, this is 7. So what is the next odd number? So if you can observe, we had 2 to this to get this, we had 2 to this to get this. So the next term should be what? 2. All right, so the next number, okay, in the sequence should be a number that if we subtract what? 17 from that number, we're supposed to get 9. So the idea is the next number is going to be, now if we observe, if we add 3 to this, we get 5. So if we add 5 to this, we have 10. If we add 7 to this, we have 17. So the next number to add should be what? 7 plus 2. So if we add 7 plus 2, which is 9, the next then becomes what? 6. That gives us the answer. But if we are asked to actually solve this problem, how do we go about solving it? So quickly, I'm going to generate the nth term so that we can be able to properly solve this problem using what the formula. Okay. So one thing I've observed is I can see the first term T1, most times we call it A, is 2, which means 1 plus 1, right? The second term is what we have is 5, which means 4 plus 1. The third term is what we have is 10, which means 9 plus 1. And the fourth term is what? We have is 17, which means what? 16 plus 1. So what can we observe from what we have on the board? We can look out here that all these here are simply what? The square of these numbers. Okay? So I can simply say this also means 1 square plus 1. I'll give me 2. Now this also means 2 square plus 1. Okay, the 1 is constant. So 2 square is 4 plus 1. That will give me 5. Now for this, we have is what? 3 square plus 1. So 3 square is 9 plus 1 is 10. That's the fourth term. So the next term is what? This means what? 4 square, okay, plus 1, which is 17. So the nth term, okay, is equals to what? So this stands as n, so it means this part is what? N. So it means n squared plus 1. Okay, that gives us the solution. So since I've developed this formula, we are now going to apply it in finding what? The fifth term, which we have been asked to find. Alright, so to find the fifth term, I'm simply going to say T5 as the fifth term. The fifth term is equal to, so what is n? So n has come 1, 2, 3, 4, so n is now 5, so I have 5 squared plus 1. Number 1 is always constant, so the fifth term is going to be 25. 5 squared means 5 plus 5 plus 1, so 25 plus 1. So the fifth term to this question is actually 26. So that gives us the answer to this problem. Alright guys, thank you guys for watching this video. Hit the like button, subscribe to this YouTube channel, share this video to your friends, loved ones, and students all over the globe. I'll see you guys tomorrow. Alright, bye.